All right, guys. So today we're going to talk a little bit about getting you prepared for this Unit 1 test. The test is basically covering all of Unit 1. So I'm going to work through some questions here. Pretty straightforward, I'm hoping. And hopefully you'll understand this better when you get done. So our first question is just to convert 26 square feet to square inches. So if you'll remember, 1 foot is 12 inches. So I think the easiest way to do this, I think of this as dimensional analysis. 26 square feet. I'm going to multiply it by, now I want to put feet on the bottom because I want to get rid of feet. If I leave it like this, though, with 12 inches over 1 foot, I'm actually not going to get rid of feet squared. So I think it's best if we remember then to get that feet squared. It ends up being just squaring the conversion factor. So rewriting this, we have 26 feet squared times 144 inches squared over 1 foot squared, right? 1 times 1 is 1. Now, if you think about this, those feet squared are out. So this becomes 26 times 144 square inches. Let me get a calculator going. This gives me 3,744 square inches. Now, the next one, this is kind of getting at one of the Fermi questions. So there are 2,300 students in RHS. Assuming each student receives 2 square feet of space, how much space do the students need? Okay, now this one, we're not really working backwards. We're actually we know how many students, we know the space. Okay, so the amount of space total would be 2,300 times 2 square feet per person. You want to think about it as one person. So person is gone, and we're just taking 2,300 and we're multiplying it by 2. I need 4,600 square feet of space. If the dimensions of the rectangular visitor's parking lot are 500 by 400, okay, so 500 by 400, can the entire student body stand in the parking lot? Okay, so what is that? That's 500 times 400. Ooh, that has an area of 200,000, and it's feet by feet. So 200,000 square feet. And the answer is yes, of course. We only need 4,600 square feet, and we have 200,000 square feet. So yes, absolutely they can. Now, if the answer was no, we would just need to subtract to find out how much more we need, because it says if not, how much extra space. But this answer is yes, so there's no subtraction needed. Yes, the student body can fit in there. Now, think about this Fermi question. How much money will be spent on school lunches by students at RHS this year? You are just giving me your best assumptions or facts that must be considered before you can even begin to answer this question. So, assumptions / facts / things you should research. You might assume half the student body buys lunch each day. I don't know that that's a fact, but I mean, we don't know if everybody buys. We don't know if it's the same number every day that buys. So maybe we'll assume half, or maybe you could say assume a quarter, but it's an assumption, right? We also need to say that lunch, let's just say lunch costs, I don't know how much lunch costs, haven't looked it up, but let's just say lunch costs $3. Maybe it does, maybe it doesn't. But we're going to assume that lunch costs $3. So these are assumptions, or these are facts that I would need to know to help me get to an answer. You might say that RHS has, we've already said, 2,300, if I could write 2,300 students. So we could use that 2,300 to get half the student body. We could multiply it. Again, I'm not asking you to give me an answer to the question. I just need you to give me facts or research or assumptions that will help me get towards an answer. There's lots and lots of different things. All right, moving on. Question number 4. You bought a 48-inch television whose screen has an aspect ratio of 16:9. Find the width and the height of the TV. Find the area of the screen. Okay, so we're going to draw this. This is kind of the first part of our TV. We have a 48-inch diagonal. Remember, this is 16:9, but we put X's on it because it's not 16 9 inches. It's 16 of something and 9 of something. That something is the same and reduced. So that's why we call it an X. This process is Pythagorean theorem. So we set it up. We need to square that 16. We need to square that 9. We need to square that 48. Continue on. Add together your x squareds. Divide by your coefficient. Now this is x squared as an answer, and I don't want x squared, I need the x. Remember, I like to keep as many decimal places as I can at this time, and then I will square root to get just x. This is where I will make my first rounding. So that x is 2.61 inches. Now that's not a dimension either. So to get my width, I'm going to do 16 times 2.61. I'm going to get 41.76 inches for the width. The height, same idea, but with the 9. Going to get 23.49 inches. And if I want the area, I need to take the two dimensions that I just found, 41.76 and 23.49, and I need to multiply those together. Right, it's an area, so length times width, or width times height in these terms. So the area is 980.94 square inches. Now, the second part of this is the same television, but now we have a letterboxed image. So I'm going to redraw using the actual dimensions. So I'm going to write it as 41.76 across the bottom and 23.49 across the side going up and down. This does say letterboxed. Letterboxed images mean sideways bars, right? Horizontal bars, maybe the other way you say that. We have letterboxed. And this image, this thing on the inside, also has its own aspect ratio. We have a 1.9 and we have a 1. But just like last time, it's not 1.9 inches or 1 inch. It is multiplied by some amount that I don't know yet. So I'm going to call it a y. I don't like using the same variable, so I don't call it an x, I call it a y. Now, you have to decide which dimension is equal. You are either going to put 1.9y equal to 41.76, or you're going to put 1y equal to 23.49. It's not both. It's one or the other. And in this situation, I'm really looking for lengths that are the same. So this 1.9 goes all the way sideways, so does the 41.76. That's what I said equal. 1.9y equals 41.76. I would not set the other one equal because this 1y only goes part of the way and the 23 goes the full way. Those are not equal. 1y is not the same length as 23.49, so I'm not setting it equal. So I'm going to divide by 1.9 here. So 41.76 divided by 1.9. And I get a y value of 21.98. Now, what that allows me to do is same way on the last one, I went back in and I found the actual width. So the width would be that 1.9. Now it doesn't ask for the width in this problem, but width is 1.9 times 21.98 or 41.76. The height it does ask about. The height is 1 times 21.98, so 21.98 inches. It doesn't ask me about the area this time. It asks me about the height of each black bar. So these two things right here, let me tell you, these are the image. To get your black bar, you're going to take the screen or the full TV and you're going to minus the image and you're going to divide by 2. So if I want the height, I'm going to take the height of the TV, 23.49, minus the image height, which is 21.98. We just found that. And I'm going to divide by 2. Let's see if I can get my screen to move, guys. Screen, move. It's not going to move for me. So I'm going to go ahead and do the calculation, and hopefully we can still see it. 23.49 minus 21.98, but then divide by 2. So the height is 0.76 inches. That's a different part of the calculation. So 0.76 inches is the height of the bars. Now, where it says to calculate the percent of the screen's area that is occupied by the image. Now, we already found the TV area. The TV area was 980.94. I need the image area. The image area would be the image width times height. So 41.76 times 21.98. We get 917.88 inches squared. So to find the screen's area occupied by the image, the percent, you're going to take the area of the image divided by the area of the TV and then multiply by 100, right, to turn it into a percent. So the 917.88 over the 980.94 and multiply by 100. Oh, sorry, I just typed in the very wrong thing, so let me try that again in my calculator. It's going to be much better. All right, when you multiply by 100, you get 93.57%. So again, you're going to need 2 different areas to do this. The area of the image is the small thing. The area of the TV is the larger one. Divide and then multiply by 100 to turn it into a percent. So 93.57%. Now tires. So tires. The width is already listed for me, 245 millimeters. The aspect ratio is also listed, 75%. The height is the first time I'm going to have to do something. Now you'll notice the height's in inches. So what I do to get height, be in millimeters first, I'm going to take that 245 and I'm going to multiply by 0.75. And I'm going to get 183.75. That's in millimeters. The conversion to get it into inches is 25.4, so we've shortcutted it and said divide by 25.4 millimeters. And we get a 7.23 inch height. Okay, so the width times the aspect ratio divided by 25.4 is going to give you the height. To get the diameter, I am then going to take 2 of the heights. So 2 times 7.23, and I'm going to add the rim, which is 16 from above. So 2 times 7.23, so 16. We're at 30.46 inches for the diameter. So again, your diameter is 2 times the height plus the rim. For your circumference, it is pi times your diameter. So 30.46 times pi, I'm getting 95.69 inches as the circumference. Now, second column, same thing. So I'm going to do this a little quicker. 275 millimeters, 75%. So take that 275 times 0.75. I get 206.25. Again, that's in millimeters, so divide by 25.4 to convert. I get 8.12 inches. So to do the height, to do the diameter, it's 2 times that 8.12 plus the rim that's above. Is 34.24 inches. And you take that and multiply by pi to get 107.57 inches. So now I've got my 2 circumferences. So how many inches further have we traveled? How many inches further implies a subtraction. So 107.57 minus 95.69. Is 11.88 inches further. B part, after one rotation, the truck with the larger tires has traveled a certain number of times further than the truck. That times further, not inches further, times further implies division. So you're going to take that 107.57 over 95.69. You get 1.12 times further, which is how we answer C and D. Remember, if the odometer reads one thing, it's based off the original tires. So I would get those 80,000 and I would multiply it by 1.12 because the larger tires are that much further every time that they spin. We get 89,600 miles. And same thing with the speedometer. If it's 60 times 1.12, your actual speed is 67.2 miles per hour. All right, so knowledge of UPC codes. This is that weighted system of a 3131313131. Okay, so valid. Let's see, we're going to multiply the first one by 3. Don't multiply the second one. Technically, you're multiplying by 1. All right, and so on and so forth. So 3, 1, and then we take a 2, and then we do the 3 and the 3. 3 and the 3. 3 and the 6. 3 and the 2. All right. I like to kind of do intermediate step and multiply each thing that needs to be multiplied. So 0, 8, 3, 2, 9, 1, 9, 7, 18, 1, 6, and 4. And I'm going to come through and actually do this addition. 0 plus 8 plus 3 plus 2 plus 9 plus 1 plus 9 plus 7 plus 18 and 1 and 6 and 4. And that gives me a 68. This is not valid. The reason we know that it's not valid is because it should be divisible by 10. Other way to say that is it ends in 0. So this is definitely not correct. So if it's not valid, since it's not valid, I would answer B. What number should you place in the last digit to make it a valid UPC code? Well, I've got to go to the closest 10. So the closest 10 to 68 means I want to go up to 70. So the last digit is the only thing that I'm concerned about, right? We have all these things, dot, 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 plus something to equal 70. Right now it equals 68. So I want to go up by 2. If I put a 6 in, that will get me up 2 to give me a 70. So up by 2, up 2 from 4 gives me a 6, and that 6 gets me up to 70. Hopefully that makes a little sense. If the closest one was down, you might be able to go down. I guess technically you could think about this as you could go to a 60, but I have to take 8 away, and I can't really take 8 away from 4. So I think it's easier to go up, although sometimes going up would put your number over 10. So just kind of work with it as moving up or moving down so that you can put a single digit in to get to a multiple of 10, the closest 10. Question 7. Your bank requires your account to have a password, 5 letters, 3 digits, 1 special character, and those are listed out for you. Okay, so 5 letters, 1, 2, 3, 4, 5. All of these are letters. 3 digits, 1, 2, 3, and 1 special character. All right, when it talks about letters, and we can repeat. Okay, we can repeat things. All right, so there are 26 letters in the alphabet. Digits, there are 10 digits. I know you think of it as being 0 through 9, and you think there are 9 digits, but there's 0 is a digit, so there are 10 digits. And then special characters, if you look above, there are 6 of those. So fill in the blanks basically, and we multiply all this out. So we have 26 to the 5th times 10 to the 3rd times 6. It's a big old number. It gives it to me as a scientific notation. So let's see what we've got here. We've got 7, 1, 2, 8, 8, 2, 5, 6. And based off mine, it's times 10 to the 10th. That decimal point was right here. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there we go. It is 71, what is that? 71,288,256,000 options. Now, B part, same setup, but some things can and cannot be repeated. All right. I like to look at my limitations first. First letter can't be a 0. Sorry, letter is an O. That's not a 0, that's an O. Big confusion. So not O. So if you can't have an O the first time, you'd have 25 letters to talk about. It says the digits cannot be repeated. So when I have 10 digits for the first one, the second one would be 9, and the next one would be 8. But everything else seems free and clear. So all my other letters are 26. And the special characters is still 6. I'm going to multiply all of this. Still a big number. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we lessened it by like 22 billion. Same idea. I tend to tell you when you have limitations, please look at those first, get those set up, and then if nothing else is mentioned, then you'd go back and kind of fill in with the larger amount of everything. All right, final question. We have a weighted average, calculating a grade. So tests are 50%. Now here's the thing, I have lots of test grades listed here. So I'm not going to put a 50% on each of them. I need to actually average my tests first. Each test is weighted the same within the test category. So I'm going to add all those up. And I'm going to divide by 4 to get a test average. My test average is 68.25. I need to do the same thing for my homework average. Add them up. Within the actual homework numbers, all the homeworks count the same. So this is just a straight average for each category, and then I will weight it at the end. So I divide by 5. My homework average is a 74.4. Class participation, I have an 87. Okay. So test average gets a 0.5. So 68.25 times 0.5. That's my 50%. Plus 74.4 times, let's see, homework is 0.15. Plus class participation, we've already got it, 87 times 0.15. Plus, I have no idea on my exam. So maybe I'll just say exam times 0.2. And in this situation, I do know the average that I want to obtain. I want at a 90 in the class. So I'm going to equal this to 90. Now, that exam, maybe we'll just call the exam X. I can't do much with it, 0.2x, but I can multiply these other things. So 68.25 times 0.5 is 34.125. I'm going to actually multiply each one of these things by what it's supposed to be multiplied by. And I'm going to add together my numbers that are like terms, right? My numbers without the x's. So 34.125 plus that 11.16 plus that 13.05. I'm going to get 58.335 plus 0.2x equals 90. This is just an equation that I solve now for x. So subtract the 58. So I have 0.2x equals 31.665. And then I divide by 0.2. And I get 158.325, so I would round that up to 159 on the exam, which you probably know is not possible. Sometimes it's impossible to get the grade you want. So there's no way to get 159 on the exam. So I'm here to tell you in this situation, you would never have a 90 in this class. So sometimes you might find a grade that's an impossibility. And that's okay. You've answered the question. It is 159 on the exam in order to get the 90. Doesn't mean it's possible to do. It just means that's what you have to get. All right, guys. So I hope that helped. You should be asking your teacher if you have any questions. Make sure you study hard for this exam. Not exam, this test, unit test. First big test of the year. Good luck, guys.